Good morning, students. So today we solve some problems on Legendre's polynomial and also generating functions. Okay. So here example 1. Prove that or show that first one Pn of 1 is equal to 1. Second one Pn of minus x is equal to minus 1 whole to the power n into Pn of x. Okay, so this is the problem. We have to show that Pn of 1 is equal to 1, and the second one Pn of minus x is equal to minus 1 whole to the power n into Pn of x. Okay, so now solution. Now as we know that generating function already we have derived the generating function in the last class, right? So we know that is summation from n is equal to 0 to infinity z raised to n into Pn of x is equal to 1 minus 2z plus z square raised to minus 1 by 2. Okay, so this we have already derived in the last class. Now this can be written as this is equal to, now see that this is of the form 1 plus z square minus 2z, or a square plus b square minus 2ab, right? So it is nothing but expansion of 1 minus z whole square. So 1 minus z whole square is equal to what? A square, then plus b square, then minus 2ab. Okay, so this is the expansion of 1 minus z whole square. So this is 1 square 1 plus z square, then minus 2z. Okay, so this is nothing but 1 minus z whole square raised to minus 1 by 2. Here this 1 2 get cancelled, and which is the same as 1 minus z whole raised to, now it is minus 1. Now using 1 minus x whole raised to minus 1, expanding that, so that is 1 plus z plus z square and so on plus z raised to n, and it continued. Or simply this is equal to summation of n is equal to 0 to infinity z raised to n. Okay, so now here we have taken on these two equation, equating the coefficient of z raised to n. Now equating the coefficient of z raised to n both sides. Okay, so now here what we have taken, in this LHS we have taken summation from n is equal to 0 to infinity z raised to n Pn of x we have taken. Okay, so now on expanding this from n is equal to 0 to infinity, so what we will get? First we will get from n is equal to 0 means n is equal to 0 means z to the power 0 is 1, then p naught of 1, since Pn of 1 is p naught of 1 is 1. Okay, so then plus it is continued. So therefore coefficient of z raised to n becomes Pn of 1 side, and here coefficient of z raised to n is equal to 1. So this is the first one. This is the first one. Next we prove the second one. To prove the second one, again consider, you know that n is equal to 0 to infinity z raised to n, Pn of 1 is equal to 1 minus 2z plus z square raised to minus 1 by 2. Now in this, put x by, sorry, Pn of x, it is Pn of x is equal to 2zx plus z square. So this is the generating function formula. Now here replace x by minus x, so which gives summation from n is equal to 0 to infinity z raised to n. Here we replace x by minus x, which is equal to, here we replace 1 minus x by minus x means minus minus becomes plus 2zx plus z square, then this is whole raised to minus 1 by 2, whole raised to minus 1 by 2. Okay. Now this can be written as now again consider the same equation here. Now replace z by minus z. Again the same equation, we replace z by minus x. First what we have done, we replaced x by minus x and we obtained this relation. Next we replace z by minus z, again the same equation. So we will get n is equal to 0 to infinity minus z whole to the power n. This is Pn of x as it is, which is equal to, and this one is same 1 1. We replace z by minus z, so here z minus minus becomes plus 2zx plus z square raised to minus 1 by 2. Again this can be written as n is equal to 0 to infinity. Now this minus z can be written as minus 1 into z whole to the power n, Pn of x is equal to 1 plus 2zx, sorry, 1 plus 2zx plus z square raised to minus 1 by 2. Again this is of the form ab to the power n, right? Ab to the power n is a raised to n into b raised to n. Okay, so as we know that by the laws of indices, a into b whole to the power n is equal to a into a raised to n into b raised to n. So this becomes n is equal to 0 to infinity, so minus 1 whole to the power n into z to the power n. Next Pn of x is equal to, this is 1 plus 2xz plus z square raised to minus 1 by 2, raised to minus 1 by 2. Okay, now so now this is equation, call this equation as 3. This is equation 3. Now next is, this is equation 2. So which one? The first one, this is equation 2. After replacing we get equation 2. Okay, so now consider from 2 and 3, from 2 and 3, right? Now from equation 2 and 3, so what we have here, 2 is, this is equal to this one. So here one thing we observe that RHS of both equation 2 and 3 are same. Now see here, in this equation the RHS is 1 plus 2zx plus z square whole raised to minus 1 by 2, and similarly in this also the RHS is 1 plus 2zx plus z square whole raised to minus 1 by 2. That means RHS of equations 2 and 3 are same. It means that LHS must be same. So LHS of equation 2 and 3 must be same. So therefore we write from equation 2 and 3 LHS of equation 2 minus 1 to the power z power n into Pn of x is equal to LHS of equation 2 is summation from n is equal to 0 to infinity, summation from n is equal to 0 to infinity z raised to n into Pn of x, sorry, Pn of minus x, Pn of minus x, Pn of minus x. Okay, so now afterwards equating the coefficient of z raised to n both sides. Okay, so then what we obtain, z raised to n coefficient here it is minus 1 whole to the power n into Pn of x is equal to, here z raised to n coefficient Pn of minus x, Pn of minus x. Okay, or Pn of minus x is equal to minus 1 to the power of n into Pn of plus x. So this is the second relation we prove now. Okay, so Pn of minus x is equal to minus 1 whole to the power n into Pn of x. So this is how we solve the problems on the generating function. Okay, so in the next class we prove some important recurrence relations, so which are very important from the examination point of view. So that we take in the next class. Today we finish up this up here only. Okay, so thank you.